The September blackout, when NASA's cameras went dark at the worst possible moment, September 3rd, 2025. Mark that date. Remember it, because on that day, something happened that should never happen in modern space exploration. A billion-dollar spacecraft, equipped with some of the most advanced imaging technology humanity has ever built, positioned itself perfectly to observe one of the most extraordinary astronomical events in recent history. The cameras were aligned, the instruments were calibrated, the moment had arrived, and then, without warning, without explanation, without any technical justification that makes sense, everything went dark. Not for minutes, not for hours, for 72 complete hours. 3 full days of absolute silence from a mission that had been flawlessly transmitting data for months. 3 days during which the most important observation window closed forever. 3 days that have left researchers, astronomers, and anyone paying attention with a single burning question: what happened during the September blackout? This is not speculation. This is not conspiracy theory. This is documented, verifiable fact that you can check yourself by visiting NASA's public image archives. The data that should exist does not exist. The photographs that should have been taken were never released. The transparency that defines modern space science was suspended for reasons that have never been adequately explained, and the object that was supposed to be photographed, an interstellar visitor that came from beyond our solar system, remains one of the most mysterious and potentially significant discoveries of our time. Tonight, we are going to examine every detail of the September blackout. We are going to trace the timeline minute by minute, decision by decision, mystery by mystery. We are going to look at what was supposed to happen, what actually happened, and what the systematic suppression of data across multiple space agencies tells us about what they might have seen. We are going to connect dots that span continents and organizations, and by the end of this investigation you will understand why this moment represents either the greatest technical failure in NASA's recent history or the most carefully orchestrated information blackout in the history of space exploration. Because this is not just about missing photographs, this is about what those photographs might have shown. This is about an object that defies conventional explanation, that behaves in ways natural comets should not behave, that arrived from interstellar space, with properties that have made some of the world's top astronomers question everything they thought they knew about what is possible in our universe. This is about the moment when our best technology finally had the chance to reveal the truth, and someone, somewhere, made the decision to turn off the cameras. Let me take you back to the beginning. Let me show you how we got here. Let me walk you through the evidence, piece by piece, until the pattern becomes impossible to ignore, and then you can decide for yourself what the September blackout really means. You can decide whether you believe the official silence, or whether you think something far more significant is being hidden behind classified doors and delayed release dates and systematic gaps in public archives. This is the story of 3i Atlas. This is the story of the September blackout. This is the story of what happens when the search for truth collides with institutional secrecy, when scientific transparency gives way to information control, when the moment of discovery becomes the moment of concealment. And this story is still unfolding, still developing, still hiding secrets that may change everything we think we know about our place in the cosmos. The mission was called Psyche. Not a household name, not as famous as Voyager or Hubble or the Mars rovers. But make no mistake, Psyche represents some of NASA's most ambitious engineering. Launched in October 2023, the spacecraft was designed for a very specific purpose: to journey to the asteroid belt between Mars and Jupiter, and study an object called 16 Psyche, a metallic asteroid that might be the exposed core of an ancient protoplanet. The scientific value of such a mission is enormous. If 16 Psyche is indeed a planetary core, studying it could teach us about how planets form, how differentiation occurs in planetary bodies, how the violent early solar system shaped the worlds we see today. The spacecraft itself is a marvel. It carries a multispectral imager capable of capturing visible light photographs with remarkable clarity. It has a gamma-ray and neutron spectrometer that can determine the elemental composition of surfaces from a distance. It has a magnetometer to measure magnetic fields, And critically for our story, it has communication systems that transmit all of this data back to Earth, where it gets processed and uploaded to public archives that anyone can access. This is not a classified military satellite. This is a civilian scientific mission funded by taxpayer dollars with an explicit mandate for public transparency. The journey to 16 Psyche takes years. The spacecraft has to travel hundreds of millions of miles through the solar system, but along the way it passes other objects. It has opportunities to point its cameras at targets of interest. And in the summer of 2025, mission planners identified an extraordinary opportunity. An interstellar object, something that did not originate in our solar system, was going to pass through the inner solar system at a distance close enough for Psyche to observe it. The object had been designated 3I Atlas, and by August 2025, astronomers around the world were fascinated by what they were seeing. 3I Atlas was not behaving like a normal comet. Observations from ground-based telescopes had revealed something deeply strange. The object was displaying a jet of material that pointed toward the sun. Now, if you know anything about comets, you know this should not happen. Comets are chunks of ice and rock. When they get close to the sun, the heat causes the ice to sublimate, turning directly from solid to gas. This outgassing creates pressure that pushes material away from the nucleus. The solar wind and radiation pressure from sunlight then push this material even further outward, creating the characteristic tail that always points away from the sun. This is basic comet physics. This is what every natural comet does. This is what we have observed in thousands of comets over centuries of astronomical study. But 3I Atlas was different. Spectroscopic analysis showed emissions of nickel and cyanide in unusual combinations. The object displayed what astronomers call an ante-tail, a feature that sometimes occurs due to viewing geometry, but in this case was pointing in a direction that did not match standard models. And most troubling of all, there was that sunward jet. Material was being expelled toward the sun, not away from it. The behavior suggested some kind of active process, some mechanism that was not explained by passive sublimation and solar radiation pressure. It suggested, to put it bluntly, that something might be controlling the direction of the outgassing. The James Webb Space Telescope had also observed 3I Atlas and found that its atmosphere was dominated by carbon dioxide. This is unusual chemistry for an object supposedly coming from the Oort cloud or from interstellar space. The composition suggested the object might have formed in a very specific region of a protoplanetary disk near what is called the carbon dioxide ice line. But if 3I Atlas formed in such a region, what was it doing traveling through interstellar space? Where had it come from? What mechanisms had ejected it from its home system and sent it on a journey that would eventually bring it through our cosmic neighborhood? These questions were swirling through the astronomical community in August 2025. Papers were being written, conferences were planning sessions on the object, and everyone knew that the real breakthrough would come when we got high-resolution images. Spectroscopy tells you what something is made of, but imaging tells you what it looks like. Imaging reveals structure. Imaging shows shape. Imaging can distinguish between a natural irregular chunk of ice and rock versus something with geometric features, with edges and angles, with forms that suggest design rather than random collision and accretion. And that is where Psyche came in. The spacecraft was equipped with exactly the kind of camera needed to capture those details. It was going to pass within range of 3I Atlas in early September. The viewing geometry would be excellent. The lighting conditions would be favorable. Mission planners had already updated the public schedule to show that Psyche would be imaging 3I Atlas on approximately September 3rd or 4th. This was announced. This was on NASA's website. This was information that the scientific community and the interested public knew about and were eagerly anticipating. The stage was set. The spacecraft was ready. The opportunity was perfect. Everything was aligned for what should have been one of the most significant astronomical observations of the decade. And then the September blackout began. September 1st, 2025. The last day that Psyche images appeared in NASA's public archive. The raw image database that mission teams use to upload every single photograph the spacecraft takes showed normal operations. Images of calibration targets, images of distant stars used for navigation. The routine data flow that characterizes a healthy, functioning spacecraft continuing its mission through deep space. September 2nd. No images in the archive. Not unusual by itself. Sometimes there are gaps in upload schedules. Sometimes data gets batch processed. Sometimes there are delays in transmission or processing that result in temporary absences from the public database. But the archive usually shows some kind of indication that data is pending, that files are being processed, that images are in the pipeline. On September 2nd, there was simply nothing. No indication of pending data, no status updates, just absence. September 3rd, the critical day. According to the mission schedule, this was when Psyche should have been imaging 3I Atlas. This was the moment everyone was waiting for. This was when the high-resolution camera should have been pointed at the interstellar visitor, capturing details that ground-based telescopes could never achieve, revealing the true nature of an object that had sparked so much debate and speculation. But the archive remained empty. No images appeared. No data flowed. The silence continued. September 4th. Still nothing. By now, researchers who regularly monitor the Psyche mission were beginning to notice the gap. Online forums where amateur space enthusiasts track spacecraft activities started discussing the absence. Questions were being asked. Had something happened to the spacecraft? Was there a technical malfunction? Had Psyche gone into safe mode? But there were no official announcements from NASA, no press releases about any problems, no statements explaining the data gap. Just silence from the agency and absence from the archive. September 5th. The gap continued. 72 hours had now passed since the last image upload. 3 full days during which one of NASA's active missions produced no public data whatsoever. And critically, 3 full days that encompassed the exact window when 3I Atlas observations should have been occurring. The timing could not have been worse. Or, depending on your perspective, the timing could not have been more deliberate. September 6th. Still dark. The community of researchers and space enthusiasts was now actively discussing the blackout. Threads appeared on Reddit. Tweets circulated asking if anyone had information. Amateur astronomers who had been following the mission started reaching out to contacts at NASA, trying to find out what had happened. But the official response was silence. No explanations were offered. No technical details were shared. The agency that prides itself on transparency and public engagement simply allowed the gap to exist without comment. September 7th. The blackout continued. By now, the absence of data was becoming impossible to ignore. This was not a routine processing delay. This was not a temporary communication issue. This was a sustained multi-day gap in the public archive of an active spacecraft during what should have been one of its most important observation windows. And still, NASA said nothing. No press briefings, no mission updates, no acknowledgement that anything unusual was happening at all. September 8th. Finally, the archive came back to life. Images began appearing again. But here is what is crucial. The images that appeared on September 8th were not images of 3I Atlas. They were routine calibration images. They were navigation photos of star fields. They were the standard operational data that the spacecraft produces as part of its normal activities. The specific images that everyone was waiting for, the high-resolution photographs of the interstellar visitor, were not among them. Those images, if they were ever taken, have never appeared in any public database. Let that sink in for a moment. A spacecraft with functioning cameras, with a clear observation window, with a published mission plan that explicitly included imaging 3I Atlas, produces no public data during the exact time frame when those observations should have occurred. And when the data flow resumes, the specific images of the target of greatest interest are simply absent, not delayed, not pending processing, not marked as forthcoming, simply gone. Now, you might think this could be explained by technical problems. Perhaps the camera malfunctioned. Perhaps the spacecraft experienced an anomaly that prevented it from imaging the target. Perhaps there was a communication failure that resulted in data loss. These are all reasonable possibilities. These are all scenarios that sometimes occur in space missions. Equipment does fail. Anomalies do happen. Data does occasionally get lost. But here is the problem with those explanations. They do not match the pattern of what we observe. If Psyche had experienced a camera malfunction, NASA would have announced it. The agency does not hide technical problems. When Mars rovers get stuck in sand, we hear about it. When Hubble has gyroscope failures, we get detailed reports. When communication is lost with a spacecraft, there are press releases and recovery efforts that are publicly documented. Technical failures in civilian space missions are not secrets. They are reported, analyzed, and addressed transparently because that is how publicly funded science is supposed to work. If the spacecraft had gone into safe mode, which is what happens when onboard computers detect a problem and automatically shut down non-essential systems, that too would have been announced. Safe mode events are significant. They require analysis and recovery procedures. They are newsworthy events that NASA routinely reports because they affect mission operations and because the public has a right to know how their investment in space exploration is performing. If there had been a communication failure, if the data had been lost in transmission, that would be noted in the archive. The database would show that observations were attempted, but files were corrupted or incomplete. There would be some record of the attempt, even if the data itself was not available, but the archive shows no such thing. It shows simply nothing at all during those critical days, as though the spacecraft was not taking images at all, as though the cameras were deliberately turned off rather than malfunctioning. And most tellingly, if any of these benign technical explanations were true, NASA would have no reason to maintain silence about it. They would explain what happened. They would provide details. They would tell the scientific community and the public that unfortunately the 3I Atlas observations could not be completed due to whatever technical issue occurred. The fact that the agency has offered no explanation whatsoever, the fact that they have allowed the gap to simply exist without comment, suggests that the situation is not adequately explained by routine technical problems. So what does explain it? What scenario makes sense of the evidence we can observe? What explanation fits the pattern of data presence followed by complete absence during a critical window followed by resumed data flow, but with the specific target images still missing? The uncomfortable answer is that the most plausible explanation is deliberate information control. The cameras were not broken. The spacecraft was not malfunctioning. The data was not lost. The images were taken, and then they were classified. They were removed from public access. They were locked away behind institutional barriers that civilian researchers cannot penetrate. This is not a comfortable conclusion. This is not an accusation I make lightly, but it is the explanation that best fits the observed facts. It explains why the gap occurred precisely during the 3I Atlas observation window. It explains why NASA has offered no technical justification for the absence of data. It explains why the archive simply resumed normal operations afterward with no apparent concern about the missing days. It explains why the specific images of greatest scientific interest have never appeared while routine operational data continued to flow before and after the blackout. And critically, this explanation becomes even more compelling when we discover that NASA was not alone. The September blackout was not an isolated event affecting only one spacecraft. It was part of a pattern that extends across multiple agencies, multiple spacecraft, and multiple observation opportunities. The systematic nature of the data suppression is what transforms this from a curious anomaly into something that demands serious investigation and explanation. While Psyche was going dark over Earth, something equally strange was happening with the European Space Agency's missions. The ExoMars Trace Gas Orbiter, a spacecraft currently in orbit around Mars, also had an observation opportunity for 3I Atlas. The Trace Gas Orbiter is equipped with instruments designed to study atmospheric composition. It has spectrometers that can analyze the chemical makeup of gases. It has cameras that can capture images in various wavelengths. And as 3I Atlas passed through the inner solar system, the Trace Gas Orbiter had the geometry and the capability to observe it. The European Space Agency operates differently from NASA in some ways, but it shares the same fundamental commitment to open science and public data access. ESA missions regularly release their data to publicly accessible archives where researchers can download and analyze the observations. The system is designed to enable widespread scientific collaboration. It is designed to make European space exploration transparent and accountable. It is designed to ensure that discoveries benefit the global scientific community rather than remaining locked behind institutional walls. But when researchers went looking for the ExoMars Trace Gas Orbiter's observations of 3I Atlas, they found something very strange in the ESA data archive. The observations were listed. They existed in the database, but they were not available for download. Instead, each file had a release date attached to it, and that release date was set for the year 2099. 2099. Let me repeat that, because the magnitude of this date needs to be understood. Not 2026. Not 2030. 2099. That is 74 years in the future. That is a date so far removed from the present that it effectively means never. It means that no scientist currently working in the field will live long enough to see the data released. It means that the information is locked away not for months or years but for multiple human generations. It means that for all practical purposes these observations might as well not exist. When this 2099 date was discovered and discussed in online astronomy forums, the initial assumption was that it must be an error. Database systems sometimes have bugs. Placeholder values sometimes get entered incorrectly. Default timestamps sometimes appear when proper dates are not specified. The year 2099 could be just a maximum value in a date field, a dummy number that got accidentally assigned to real data files. This happens. Metadata problems occur in complex information systems. It was entirely reasonable to assume this was just a glitch that would be corrected once someone at ESA noticed and fixed it. But then something interesting happened. The dates changed. Not all of the files reverted to immediate availability. Instead, many of them shifted to a new date. April 3rd, 2026. Suddenly, researchers who had been looking at data that would not be released for 74 years were being told that actually they could access it in about 6 months. The embargo had been dramatically reduced, but it had not been eliminated. The data was still being withheld, the release was still being delayed. The only difference was that now the delay was measured in months rather than decades. This date change is actually more revealing than the original 2099 timestamp. Because you do not accidentally change dates in a database. You do not randomly shift embargo dates from one value to another through technical glitches. Date changes require human intervention. Date changes require someone to go into the system, access the file metadata, and deliberately modify the release schedule. The shift from 2099 to April 3, 2026 was a conscious decision made by people within the European Space Agency. It was an acknowledgement that data exists, that it will eventually be released, but that for now it needs to remain inaccessible to the public. Why April 3, 2026? That is a very specific date. Not April 1st or April 15th, or simply sometime in April. April 3rd. Someone chose that date for a reason. Someone decided that this particular moment, 6 months after the observation, would be the appropriate time to make the data available. But what changes between October 2025 and April 2026? What analysis needs to be completed? What reviews need to occur? What coordination needs to happen? That requires half a year of embargo on data that in normal circumstances would be released within weeks or months at most. The standard practice in astronomy is that data embargoes exist to give the team that planned and executed the observations time to do their initial analysis and publish their findings before the raw data becomes public. This is considered fair. These teams invest years in preparing observation proposals, getting them approved, waiting for their scheduled time on telescopes or spacecraft, and they deserve the opportunity to be the first to publish results from their work. But these embargoes are typically measured in weeks or a few months. Not half a year, not 74 years. The length of the delay for 3I Atlas data is completely outside the normal range. And when you combine the ESA embargo with the NASA blackout, a pattern emerges. Both agencies, one American and one European, both nominally committed to open science and public transparency, both operating civilian rather than military missions, both funded by public money and accountable to democratic institutions, somehow both decided that observations of 3I Atlas needed special handling. Both decided that the normal procedures for data release would not apply. Both decided that the public and the broader scientific community would not get immediate access to what their spacecraft observed. This is not coincidence. This is not two independent technical glitches happening simultaneously. This is coordinated behavior. This is a systematic approach to information control that spans organizations and continents, and the question we have to ask is why. What did these spacecraft observe that led to such an unusual response? What properties did 3I Atlas display that convinced multiple space agencies to break with their normal practices of transparency? What images or spectra or measurements were captured that required this level of restricted access? Before we can answer that question, we need to understand what was already known about 3I Atlas before the September blackout occurred. Because the object had already revealed characteristics that were raising eyebrows among astronomers, the public observations that were available, the data that had been collected by ground-based telescopes and by other instruments before the high-resolution spacecraft observations were scheduled, had already painted a picture of something highly unusual. The discovery of 3I Atlas came from automated sky surveys that constantly scan the heavens looking for objects that move against the background of distant stars. When something in the solar system moves, it appears to shift position from night to night. By taking images separated by hours or days and comparing them, astronomers can identify asteroids, comets, and other solar system objects. This is how most comets are discovered today. Not by amateur astronomers peering through telescopes, but by sophisticated automated systems that process millions of images looking for anything that moves. 3I Atlas was flagged as unusual almost immediately. Its trajectory was wrong. When you track an object over multiple nights, you can calculate its orbit. You can determine where it came from and where it is going. Most objects in the solar system have orbits that are bound to the Sun. They go around in ellipses, returning to the inner solar system periodically. Even long-period comets that take thousands of years to orbit still have paths that keep them gravitationally attached to our star. But 3I Atlas had a hyperbolic trajectory. Its path was not a closed loop. It was passing through the solar system on a one-time visit. It came from somewhere else, and after its passage through the inner system it would leave forever, heading back out into interstellar space. This made 3I Atlas only the third confirmed interstellar object ever detected. The first was Oumuamua in 2017, an object that sparked enormous controversy because of its strange properties. Oumuamua accelerated as it left the solar system without any visible outgassing that would explain the acceleration. It had an elongated shape, unlike any natural comet or asteroid we had seen before, and its odd characteristics led some scientists, most notably Avi Loeb from Harvard, to publicly suggest that it might be artificial, might be a probe or debris from an extraterrestrial civilization. The second confirmed interstellar object was Borisov, discovered in 2019, which behaved much more like a normal comet and did not generate the same level of controversy. 3I Atlas appeared to fall somewhere between Oumuamua and Borisov. It displayed comet-like activity, showing a coma and tail that suggested outgassing. But the details of that activity were strange. When professional observatories pointed their instruments at the object and began collecting detailed spectroscopic data, they found chemical signatures that did not quite fit standard comet models. The Keck Observatory in Hawaii, one of the premier astronomical facilities in the world, used its spectrometers to analyze the light coming from 3I Atlas. Spectrometry works by splitting light into its component wavelengths. Different elements and molecules emit or absorb light at specific wavelengths, creating a unique fingerprint. By analyzing the spectrum of light from a comet, astronomers can determine what gases are being released as the ice sublimates. The Keck spectra of 3I Atlas showed emissions from nickel and cyanide. Now, both of these species do appear in some comets. They are not unheard of. But the combination and the intensity were unusual. Nickel in particular is not commonly abundant in comet atmospheres. Its presence suggested that metallic components were somehow being vaporized from the object, and cyanide, while present in some cometary ices, appeared in concentrations that raised questions about the object's formation history. The James Webb Space Telescope, which had recently become operational and was revolutionizing astronomy with its infrared capabilities, also observed 3I Atlas. Webb spectroscopy revealed that the object's atmosphere was dominated by carbon dioxide. This was actually one of the clearer results. Carbon dioxide ice is common in the outer solar system. It exists on Mars. It exists in comets that form beyond the frost line where temperatures are cold enough for CO2 to freeze. The presence of carbon dioxide itself was not strange. What was strange was the implication of where the object must have formed. If 3I Atlas formed in a protoplanetary disk around another star, the dominance of carbon dioxide suggests it formed near the CO2 ice line, a specific distance from the star where temperatures drop low enough for carbon dioxide to condense. This is a relatively warm part of a protoplanetary disk compared to where traditional Oort cloud objects form. So either 3I Atlas formed in an unusual location in its home system, or it underwent processing that depleted other volatile species and left carbon dioxide as the dominant component. Either way, it suggested a more complex history than a simple chunk of ice ejected from the outer reaches of another solar system. But the most troubling observation, the one that received the most attention and generated the most discussion, was the sunward jet. Ground-based telescopes and space-based observatories both detected material being expelled from 3I Atlas in a direction that included a component toward the Sun. This is fundamentally wrong according to basic comet physics. Comets are passive objects. They do not have engines. They do not have directional control. The forces acting on them are gravity pulling them toward massive bodies and radiation pressure pushing material away from the Sun. These forces should produce outgassing and tails that point away from the Sun, not toward it. One possible explanation for a sunward jet is a rotating nucleus. If the comet is spinning and jets are emanating from specific active regions on the surface, the rotation could sometimes orient those jets such that they appear to point toward the Sun from certain viewing angles. This is a known phenomenon. It has been observed in other comets. But in those cases, the overall structure still makes sense within the framework of natural comet behavior. The jets are still fundamentally driven by solar heating and sublimation. The rotation just affects the direction of the ejected material. But what observers were seeing from 3I Atlas did not quite fit this explanation either. The sunward component of the jet appeared too persistent, too consistent across multiple observation epochs. If it was just a rotation effect, you would expect the apparent direction to change as the viewing geometry changed and as the comet's rotation carried different regions into and out of sunlight. But the sunward jet seemed to maintain its general orientation in a way that suggested something more than passive rotation and sublimation. This is where speculation begins to creep into the scientific discussion. This is where researchers start to consider possibilities that would normally sound too far-fetched to publish. But when the evidence does not fit conventional models, when the observations defy standard explanations, scientists have a responsibility to consider alternatives. And one alternative that was being quietly discussed in conference hallways and late-night conversations between colleagues was that the sunward jet might not be passive at all. It might be active. It might be controlled. Imagine for a moment that 3I Atlas is not a natural comet. Imagine that it is a probe, an artifact, a piece of technology sent by an extraterrestrial civilization to explore other star systems just as we are planning to do with our own interstellar missions. Such a probe would need propulsion. It would need attitude control. It would need the ability to adjust its trajectory and orientation as it traveled through the galaxy. And one way to achieve this would be through some form of outgassing, venting material in controlled directions to create thrust. If such a probe was approaching a star, it might need to dump excess heat. It might need to recharge solar panels or other power systems. It might need to perform course corrections to ensure it passed through the inner system at the right distance and trajectory to maximize its scientific observations. All of these activities could produce jets of material, emissions of gas and particles, that would not follow the patterns we expect from natural sublimation driven by solar heating alone. Now, I want to be very clear. This is not what NASA or ESA or any professional astronomer was publicly stating as the most likely explanation for 3I Atlas. The official position, to the extent that anyone was taking an official position, was that the object was probably a natural comet with some unusual characteristics that would eventually be explained as more data became available. The idea that it might be artificial was considered highly speculative, extraordinarily unlikely, and not supported by enough evidence to warrant serious consideration in peer-reviewed literature. But the idea was out there. It was being discussed, and critically, it was being discussed before the September blackout occurred. The astronomical community was already aware that 3I Atlas was strange. They already knew that its behavior did not perfectly match standard comet models. They already understood that high-resolution imaging would be crucial for determining whether the object's structure was consistent with a natural body, or whether it showed geometric features that would be harder to explain. And then, precisely when those high-resolution images should have been captured, the cameras went dark. The data vanished, the archives went silent, and the question that cannot be escaped is whether the timing of the blackout is connected to what the instruments were seeing. Whether someone reviewed preliminary data from Psyche or from ground-based observations and made a decision that this information needed to be controlled rather than released. Whether the September blackout was not a technical failure at all, but a deliberate response to a discovery too significant to share without careful consideration of the implications. To understand just how systematic the information control has been, we need to look beyond just Psyche and the ExoMars Trace Gas Orbiter. We need to examine all of the observation opportunities that existed for 3I Atlas and what happened to each of them. Because when you map out the complete timeline, when you see every moment when a high-resolution instrument could have revealed the truth, the pattern of withheld data becomes impossible to dismiss as coincidence or technical problems. The Mars Reconnaissance Orbiter has been one of NASA's most successful Mars missions. Launched in 2005, it has been orbiting the red planet for nearly 2 decades, returning an enormous volume of high-resolution imagery. The spacecraft carries a camera called HiRISE, which stands for High Resolution Imaging Science Experiment. HiRISE is not just any camera, it is one of the most powerful imaging systems humanity has ever sent into deep space. From its orbit around Mars, HiRISE can capture images with a resolution of about 30 centimeters per pixel. To put that in perspective, it can see your car from Mars orbit. It can photograph individual rocks the size of a beach ball from thousands of kilometers away. HiRISE was designed primarily to study the Martian surface. Its job is to capture detailed images of geological features, potential landing sites for future missions, and areas of scientific interest. But there is no rule that says HiRISE can only photograph Mars. The camera can be pointed at other targets if the opportunity arises, and if mission planners decide the science justifies using the instrument in that way. And in October 2025, a very interesting opportunity arose. 3I Atlas was going to pass close to Mars, not so close that it would be a threat, but close enough that HiRISE could photograph it. Think about what that means. TRISE can resolve features 30 centimeters across from Mars orbit. If 3I Atlas passed within even a few million kilometers of Mars, HiRISE could potentially capture images showing details that no ground-based telescope could possibly achieve. It could photograph the nucleus of the object. It could reveal surface structures. It could show whether the object was a smooth, irregular blob like most comets, or whether it had features that suggested something else. Edges, angles, geometric patterns. Anything that would indicate this was not simply a natural chunk of ice and rock. So did HiRISE observe 3I Atlas? That is the question. And the answer is that we do not know because no HiRISE images of the object have been released to the public. The Mars Reconnaissance Orbiter website, where all HiRISE images are normally uploaded for anyone to view and download, shows no images of 3I Atlas. The team that operates HiRISE has made no announcements about any observations. There are no press releases. There are no scientific papers using HiRISE data of the object. There is simply silence. Now, it is entirely possible that HiRISE did not attempt to observe 3I Atlas. Mars mission time is precious. Every observation opportunity represents a choice between different scientific targets. The mission's primary purpose is studying Mars, and the team might have decided that Martian science took priority over photographing an interstellar visitor. That would be a legitimate decision. It would be disappointing from the perspective of those interested in 3I Atlas, but it would be understandable given the mission's mandate. But here is what is strange. There has been no statement either way. If HiRISS attempted the observation and captured useful images, where are they? If HiRISS did not attempt the observation because other priorities took precedence, why not just say so? The pattern we see with 3i Atlas is not just missing data, it is missing communication. It is missing conformity. It is a systematic absence of information that extends even to whether observations were attempted at all. The same pattern appears with other Mars orbiters. ESA's ExoMars Trace Gas Orbiter was not the only spacecraft in Martian orbit during the 3i Atlas flyby. NASA also operates MAVEN, the Mars Atmosphere and Volatile Evolution mission, which has instruments for studying atmospheric composition and escape. Theoretically, MAVEN could have contributed observations of 3i Atlas's atmosphere or outgassing, but no MAVEN data on the object has appeared in public databases. The Indian Space Research Organisation also operates a Mars orbiter, the Mars Orbiter mission, which carries cameras and instruments. India's mission could have observed 3i Atlas as well, but again no data has been released, and no statements have been made about whether observations were even attempted. What we have is a systematic absence of high-resolution imagery from every platform that had the opportunity to capture it. Ground-based telescopes could observe 3i Atlas and did, producing the spectroscopic data and lower-resolution images that revealed its unusual properties. But every spacecraft with high-resolution imaging capabilities that had an observation window either went dark during that window, or has not released any data, or has set such distant embargo dates that the data might as well not exist. The pattern is too consistent to be coincidental. Individual technical failures happen. Individual decisions not to observe a particular target happen. But systematic absence across multiple spacecraft, multiple agencies, multiple countries, all for the same object during the same time period, suggests coordination. It suggests that someone at a level above individual mission teams made a decision that 3i Atlas observations would be handled differently from normal scientific data. There is one more spacecraft we need to discuss, and its involvement in this story is still developing. The Europa Clipper mission launched in October 2024 with the goal of studying Jupiter's moon Europa. Europa is one of the most exciting targets in the solar system because beneath its icy shell lies a global ocean that might harbor life. The Clipper mission will make multiple close flybys of Europa using its instruments to study the ice shell, search for evidence of water plumes erupting from the surface, and gather data that will inform future missions that might attempt to land and drill through the ice. But Europa Clipper is currently in transit. It is on its way to Jupiter and will not arrive for several years. Along the way, it is traveling through the inner solar system, and in late October 2025, its trajectory took it through a region where 3i Atlas could potentially be observed. The spacecraft carries cameras and spectrometers. It has the technology to image distant objects during its cruise phase, and mission planners would have known about the 3i Atlas opportunity. So the question is whether Europa Clipper will observe the object, and more importantly, if it does, will that data be released? As of this moment, we do not know. The observations, if they happen, would be taking place right around now. The data, if collected, would take some time to transmit back to Earth and process. We might not see results for weeks or months, even under normal circumstances. But given the pattern we have observed with every other high-resolution observation opportunity, there is legitimate concern that Europa Clipper data, if it exists, will follow the same pattern. It will be delayed, it will be embargoed. It will vanish into the same black hole that has consumed every other detailed observation of this object. And if that happens, if Europa Clipper data is also withheld, then we will have confirmation that the information control is not limited to a few spacecraft or a couple of space agencies. We will have confirmation that there is a systematic policy, perhaps agreed upon by multiple governments, perhaps coordinated through international treaties or agreements, that observations of 3i Atlas are to be classified or restricted regardless of which spacecraft collects them. This brings us to the most uncomfortable question. If the data is being systematically withheld, if observations are being classified or embargoed across multiple platforms and agencies, what does that tell us about what the data actually shows? What could possibly justify this level of information control? What discovery could be significant enough that democratic governments with traditions of scientific transparency would decide to keep it secret? There are really only two possibilities. The first is that 3I Atlas presents some kind of threat that authorities want to understand before causing public panic. Perhaps the object's trajectory, while currently not intersecting Earth, could be altered by gravitational interactions in ways that might make it dangerous in the future. Perhaps its composition includes materials that could be hazardous if fragments entered Earth's atmosphere. Perhaps something about its behavior suggests it could affect spacecraft or satellites if it passed through certain orbital regions. Under this scenario, the data is being restricted while experts assess the risk and develop plans for how to communicate that risk to the public without causing unnecessary alarm. But this explanation has problems. First, 3I Atlas's trajectory is well known. It has been tracked by multiple observatories. Its path through the solar system has been calculated and published. If it represented a collision threat, that would be impossible to hide because the orbital calculations are public. Independent astronomers could verify any claims about where the object is going. Second, comets and asteroids pass through the solar system all the time. We have entire programs dedicated to tracking potentially hazardous objects. When real threats are identified, they are announced and discussed openly. There is no precedent for hiding information about a potentially dangerous object because historically that approach has never been considered viable or appropriate. The second possibility is that 3I Atlas is not natural, that the high-resolution imagery revealed structures or features that cannot be explained by natural processes, that the object shows signs of design, of engineering, of artificiality, that what was supposed to be a comet turned out to be something made, something built, something sent by an intelligence that is not human, and that this discovery is so profound, so worldview-shattering, so politically and socially destabilizing, that authorities decided it could not be immediately released to the public. This explanation would account for everything we observe. It would explain why data is being withheld across multiple agencies and nations. It would explain why the blackout occurred precisely when the highest resolution observations were being made. It would explain why even the fact of the observations is being obscured, why there are no statements about what was seen or why the data is being delayed. Because if the data shows evidence of extraterrestrial technology, if it provides confirmation that intelligent life exists beyond Earth, and that artifacts from other civilizations can and do visit our solar system, then the implications are so enormous that any government would want time to analyze, to verify, to prepare, and to coordinate an international response before making any public announcement. I am not saying this is definitely what happened. I am not claiming that 3I Atlas is proven to be artificial or that there is confirmed evidence of extraterrestrial technology. What I am saying is that the pattern of systematic information suppression is real. It is documented. It is verifiable. And this explanation of why it is happening is consistent with the evidence in a way that technical failures or routine scientific embargoes are not. Consider the historical precedent. When Oumuamua was discovered in 2017 and its strange properties became apparent, there was public discussion about whether it might be artificial. Scientists like Avi Loeb published papers arguing that the evidence was consistent with a manufactured object. Other scientists strongly disagreed and argued that natural explanations were still viable. But critically, the debate was public. The data was available, researchers could analyze it, argue about it, and come to their own conclusions. That is how science is supposed to work. But with 3I Atlas, we are not getting that open debate. We are not getting access to the data that would allow independent analysis. We are not even getting acknowledgement that the observations exist. We are getting a blackout. We are getting systematic suppression. We are getting coordinated information control that spans agencies and nations, and that level of secrecy suggests that whatever was discovered is considered too important, too sensitive, or too controversial to be handled through normal scientific channels. There is another aspect of this story that deserves attention. The people who work at NASA and ESA and other space agencies are not cartoon villains engaged in conspiracies for the sake of secrecy. They are scientists and engineers who got into this field because they love discovery and want to expand human knowledge. Most of them believe deeply in the principles of open science and public access to information. So if data is being withheld, if observations are being classified, it is not because faceless bureaucrats arbitrarily decided to be secretive. It is because someone, somewhere up the chain of command, made a determination that this specific case warranted an exception to normal transparency practices. That decision would not be made lightly. It would require justification. It would require a rationale that was considered compelling enough to override the institutional commitment to openness. And the question is, what rationale could be that compelling? What discovery could convince dedicated scientists to participate in or at least tolerate the suppression of data that under normal circumstances they would insist on releasing immediately? One possibility is that they are following protocols. Not protocols that are publicly known or discussed, but protocols that exist for exactly this kind of scenario. Government agencies do have classified frameworks for how to handle potential contact with extraterrestrial intelligence. These frameworks exist even though they are not widely publicized. They exist because at some level governments have always recognized that if we ever detect evidence of extraterrestrial life or technology, the discovery would have enormous implications for national security, social stability, religious institutions, and the entire framework of how humanity understands its place in the universe. These protocols are not the result of conspiracy. They are the result of planning. They are contingency plans developed by serious people who recognize that someday, maybe not today, maybe not in our lifetimes, but someday we might make a discovery that would require careful handling. And if 3i Atlas represents that discovery, if the high-resolution images showed something that triggered these protocols, then what we are witnessing is not arbitrary secrecy. We are witnessing the implementation of plans that were made decades ago for exactly this scenario. But even if that is the case, even if there are legitimate reasons related to carefully considered protocols, the question remains whether this level of secrecy is appropriate in a democratic society. Whether the public has a right to know about discoveries made with their tax dollars using civilian spacecraft operating under mandates of transparency. Whether the benefits of information control, whatever those benefits might be, outweigh the costs of breaking the trust that is supposed to exist between scientific institutions and the people who fund them. These are not easy questions. I do not pretend to have simple answers, but they are questions we need to be asking. Because right now, in October 2025, as 3i Atlas continues its journey back out into interstellar space, as the window for additional observations grows smaller every day, we are being denied access to information that might be the most significant scientific discovery in human history. And we are being denied that access without explanation, without justification, without even acknowledgement that the denial is happening. The April 3rd, 2026 date looms in the future. That is when the European Space Agency has promised to release its data, 6 months from now, and the question is whether that promise will be kept, whether the data will actually flow to public archives, whether researchers will finally be able to analyze the observations and come to their own conclusions about what 3i Atlas really is. But given the pattern we have observed, given the systematic nature of the information control, there is real concern that April 3rd might not bring the transparency we are hoping for. The date might be pushed back again. New reasons for delay might be discovered. The data might be released but with key details redacted or withheld. We might find that the embargo was just the first layer of a more complex information management strategy designed to control not just whether the data is released, but how it is interpreted and what conclusions the public is allowed to draw from it. And if that happens, if April comes and goes without real transparency, then we will know for certain that the September blackout was not an isolated incident. We will know that we are living through a moment of managed disclosure, where information about an extraordinary discovery is being parceled out in carefully controlled doses rather than released all at once through normal scientific channels. We will know that the authorities have decided, rightly or wrongly, that this discovery is too important to be handled through the usual mechanisms of peer review and open publication. What should we do with this knowledge? How should we respond to the systematic suppression of information about 3i Atlas? The first step is awareness. People need to know that this is happening. The September blackout needs to be discussed. The embargo dates need to be questioned. The absence of high-resolution imagery needs to be explained. As long as the information control remains largely unnoticed, as long as most people are not even aware that observations were withheld, the authorities face no pressure to increase transparency. But if enough people start paying attention, if researchers and journalists and citizens start demanding answers, if the story of 3I Atlas and the September blackout becomes widely known, rather than relegated to niche astronomy forums, then the pressure for disclosure increases. Governments and space agencies respond to public interest. They respond to media attention. They respond to demands for accountability from the people who fund them. The second step is documentation. Everything that is publicly available about 3I Atlas should be preserved and analyzed. The spectroscopic data from ground-based observatories, the trajectory calculations, the images that were released before the blackout. All of this information needs to be archived and studied, because it might be all we ever get. If the high-resolution spacecraft observations remain classified forever, then the public data, limited as it is, becomes our only window into understanding what this object really was. The third step is vigilance about future observations. 3I Atlas is leaving the inner solar system, but it has not left the observable universe. There are still telescopes that can track it. There are still instruments that can study it as it recedes into the distance. Every new observation opportunity needs to be monitored. Every data release needs to be checked. If the pattern of suppression continues, if future observations are also withheld or delayed, then the case for systematic information control becomes stronger. But if at some point the data starts flowing freely, if transparency is restored, then we might learn that the September blackout was an anomaly rather than a permanent policy. And the fourth step is preparation for disclosure. Because at some point, whether it is April 2026 or years from now, at least some of the withheld data is likely to become public. Space agencies cannot classify civilian science observations forever. The political will required to maintain secrecy indefinitely is enormous, and it tends to erode over time as personnel change, as priorities shift, as the reasons for classification become less compelling or get forgotten. When that data finally emerges, when we see the images that were taken during the September blackout, we need to be ready to analyze them objectively, to assess what they show, and to demand follow-up observations if the initial results are as extraordinary as some suspect they might be. Because here is the thing. If 3I Atlas is natural, if it is just a comet with some unusual but ultimately explicable properties, then there is no reason for the secrecy. Natural phenomena do not threaten governments. Comets do not undermine social structures. The observation of a natural object, however strange, would be a scientific curiosity but not a crisis that requires information management. So the very fact that information is being managed suggests that what was discovered is not natural, or at least it suggests that authorities believe it might not be natural and they want time to be absolutely certain before making any announcements. And if 3I Atlas is artificial, if the high-resolution images show geometric structures or technological features or anything else that cannot be explained by natural processes, then we are living through one of the most important moments in human history. We are living through the transition from believing we are alone in the universe to knowing we are not. We are living through the confirmation that intelligent life exists beyond Earth, that other civilizations explore the cosmos, and that their artifacts can reach our solar system just as someday our own probes might reach theirs. That would be extraordinary. That would be transformative. That would change everything about how humanity understands itself and its place in the universe. And if that is what the September blackout is really about, if that is why the cameras went dark at the most critical moment, then the secrecy, while frustrating and arguably inappropriate, at least makes sense from a certain perspective. Because announcing something that profound, something that challenges every assumption about our cosmic solitude, would require preparation. It would require coordination. It would require careful thought about how to present the information in a way that educates rather than terrifies, that inspires curiosity rather than panic, that brings humanity together rather than driving us apart. But even if we grant that such preparation might be necessary, the question remains how long is appropriate. How many months or years should pass before the public is trusted with the truth? At what point does protective secrecy become unacceptable information suppression? These are questions that the authorities managing this situation need to answer, and they need to answer them soon, before the credibility of scientific institutions is further eroded by the perception that important discoveries are being hidden from the very people whose support and funding make those discoveries possible. The September blackout happened. That is not speculation or conspiracy theory, that is documented fact. The data that should exist in NASA's archives does not exist. The images that should have been taken were never released. The observations that were planned were never shared with the scientific community or the public. This is real. This is verifiable. This is happening right now as we speak. The question is why? Why did the cameras go dark? Why has the data been suppressed? Why are multiple space agencies coordinating to restrict access to observations of a single object? The answers to these questions might be mundane. There might be technical explanations or bureaucratic complications that account for everything without requiring any assumption of extraordinary discoveries or coordinated secrecy. But if those explanations exist, why have they not been provided? Why does the silence continue? Why does the blackout persist, not just in the data but in the communication about the data? The most plausible explanation, the one that fits the observed pattern best, is that something significant was discovered. Something significant enough to trigger protocols for information management. Something significant enough to justify breaking with decades of established practice regarding transparency in civilian space science. Something significant enough that multiple governments and space agencies have decided, at least for now, that the public should not have access to the observations. And that raises the most important question of all. When will we be allowed to see what they saw? When will the data be released? When will the truth about 3I Atlas finally emerge from behind the classified barriers and embargo dates and systematic silences that currently surround it? Because we deserve to know. This is our spacecraft. This is our mission. This is our solar system. This is our universe. And if something extraordinary is visiting, if something from beyond our cosmic neighborhood has come to explore our star, then that discovery belongs to all of humanity, not just to the small group of officials and scientists who currently control access to the classified images. The September blackout may have ended in terms of the resumption of normal data flow from Psyche. But the real blackout continues. The blackout of information about 3I Atlas persists. The blackout of transparency persists. The blackout of trust between scientific institutions and the public persists. And until that blackout ends, until the data is released and the questions are answered and the truth is finally shared, we will remain in the dark, wondering what NASA's cameras saw during those 72 hours when everything went silent. The universe is vast. The cosmos is ancient, and in all that vastness and all that time, Earth is a tiny blue dot orbiting an average star in an unremarkable region of a common galaxy. The idea that we are alone, that in all of space and all of time only we have developed intelligence and technology and the drive to explore, has always seemed statistically unlikely. Most scientists believe that life probably exists elsewhere, that intelligence probably evolved on other worlds. That right now, somewhere in the galaxy or beyond, other civilizations are looking at their skies and wondering the same questions we wonder about whether they are alone. But believing something abstractly and having concrete evidence are very different things. We have believed that other civilizations might exist for decades. We have searched for radio signals. We have looked for biosignatures in exoplanet atmospheres. We have sent messages into space announcing our presence. But we have never had proof. We have never had confirmed contact. We have never seen an artifact or a signal, or any evidence that definitively demonstrates we are not alone. Until perhaps now. Until 3I Atlas. Until an object from interstellar space displayed properties that do not quite fit natural explanations. Until our most advanced imaging systems were positioned to reveal the truth. Until the moment when discovery should have occurred and the cameras went dark instead. Is this the moment? Is this the confirmation? Is this when humanity transitions from speculation to knowledge about our place in a populated cosmos? We do not know yet. The data that would answer that question is locked away, but the pattern of secrecy, the systematic suppression, the coordinated information control across multiple agencies and nations, all suggest that someone, somewhere, thinks this might be that moment. Someone has decided that what the cameras saw during the September blackout is too important to be treated as routine scientific data. And so we wait. We watch the calendars. We monitor the archives. We count down to April 3rd, 2026, hoping that date will bring transparency rather than new delays. We pressure the authorities for answers. We demand the truth that taxpayer-funded missions are supposed to provide. We refuse to accept that silence is an adequate response to questions about what might be the most significant discovery in human history. Because whether 3I Atlas is natural or artificial, whether it is a comet or a probe, whether the September blackout was a technical glitch or a deliberate suppression, we deserve to know. The search for truth should not stop at the boundaries of what authorities consider safe to reveal. The pursuit of knowledge should not be subordinated to concerns about social stability or institutional control. The right to understand our universe should not be revocable based on unpublished protocols and classified decisions. The September blackout happened. The cameras went dark. The data was suppressed. And until those facts are adequately explained, until transparency is restored, until we see what our spacecraft saw when it looked at the stranger from beyond, the mystery will remain, the questions will persist, and humanity will continue to wonder what truth is being hidden behind the deliberate silence of institutions that claim to serve the cause of expanding human knowledge. This is our moment. This is our mystery. This is our right to know. And the September blackout, whatever it ultimately means, will stand as either a temporary aberration in the history of open science, or as the beginning of a new era where the most important discoveries are managed rather than shared, controlled rather than celebrated, hidden rather than revealed. The choice of which path we follow is being made right now, by the authorities who control the data, by the scientists who remain silent about what they might know, by the public who either demands accountability or accepts the blackout without question. This story is not over. The September blackout may have ended, but the larger blackout of truth continues, and it will continue until we collectively decide that the right to know is more important than the comfort of managed ignorance. What did NASA see when Psyche pointed its cameras at 3I Atlas on September 3, 2025? What images were captured during those 72 hours of darkness? What truth is hiding behind the classified barriers and the embargo dates and the systematic silences? We do not know yet. But we will keep asking. We will keep pushing. We will keep demanding that the institutions we fund and support honor their commitment to transparency and truth. Because the September blackout was not just a gap in a data archive. It was a test. A test of whether scientific institutions can maintain public trust when faced with discoveries they find uncomfortable or difficult. A test of whether democratic societies can handle extraordinary truths or need to be protected from them. A test of whether the search for knowledge is truly open or whether it operates within limits imposed by authorities who have decided some truths are too dangerous to share. And how we respond to this test, how we handle the September blackout and everything it represents, will determine not just what we learn about 3I Atlas, but what kind of future humanity will have as it continues to explore the cosmos and confront the profound questions that exploration inevitably raises about who we are and whether we are alone. The answer is out there. In classified files, in delayed data releases, in images taken by cameras that went dark at the worst possible moment, the answer exists. And someday, whether through official disclosure or eventual leaks or the simple passage of time that erodes all attempts at permanent secrecy, we will know what NASA saw. We will understand what the September blackout was really about, and we will finally have the truth about the visitor from beyond that passed through our solar system while our cameras inexplicably and inexcusably looked away. Until then, we remain in the dark, but we remain watchful, we remain curious, we remain committed to the search for truth, even when that search is obstructed by those who claim to be conducting it. Because that is what it means to be human, to look up at the stars and demand to know what is really there, to refuse to accept comfortable lies when uncomfortable truths are within reach, to insist that knowledge belongs to everyone, not just to the privileged few who control the telescopes and spacecraft and classified databases. The September blackout is not over. Not really. Not until the truth comes out. Not until the data is released. Not until we see what our instruments saw and can judge for ourselves whether the secrecy was justified or whether we have been denied access to the most important discovery of our lifetimes for reasons that will someday seem inexcusable. The stars are still there. The universe is still vast. And somewhere out there, 3i Atlas continues its journey, carrying with it secrets that someone decided we are not ready to know. But ready or not, the truth has a way of emerging. Light has a way of penetrating darkness, and the September blackout, like all attempts to suppress knowledge, will ultimately fail. The only question is how long we will have to wait, and whether, when the truth finally emerges, we will still have time to understand its implications and act on what we learn. Because if 3i Atlas was artificial, if it was a probe from another civilization, then it was not alone. Where one visitor has come, others might follow. And if we are to be ready for that future, if we are to handle contact with intelligence beyond Earth in a way that benefits rather than harms humanity, then we need to start preparing now. Not after years of secrecy, not after managed disclosure parcels out carefully selected facts, now, with full transparency, with honest discussion, with the courage to confront extraordinary possibilities rather than hiding from them behind classification stamps and embargo dates. This is the challenge of the September blackout, not just to discover what happened, but to decide what kind of civilization we want to be, one that hides from truth, or one that pursues it, one that trusts its citizens with reality, or one that offers them comfortable fictions, one that explores the cosmos with eyes wide open, or one that deliberately looks away when the view becomes too unsettling. The cameras went dark on September 3, 2025. But our determination to see what they saw, to know what they recorded, to understand what really happened during those 72 hours of silence, that determination will not go dark. It will persist. It will grow stronger. And eventually it will overcome the barriers that currently separate us from the truth about the visitor from beyond, and the September blackout that hid it from view.